Hi, it's Motion Mike with a quick demonstration of Axis Test Mode Release 2. Today's demonstration uses FactoryTalk Logix Echo V3 and Logix Designer version 36. Let's say I'm a controls engineer at a machine builder and we're building a winder. Maybe it's early in the development cycle, or there have been some supply chain delays, or maybe the machine build just is taking longer than expected. But I'd like to test my motion and safety logic in parallel with the development rather than being squeezed at the end in order to meet the ship date. Here's my winder project, and I'm using an Echo controller to test my logic. It's a single axis system that might represent a tire manufacturing cell or a print roller, but for today's demonstration, it's a spindle on my winder unwinder. I've got a Kinetics 5700 ERS4 drive chosen because it includes some advanced safety capabilities. And I'll be using the safety encoder that's provided in my VPC motor that I chose for my spindle. You can see that the spindle axis is safe torque off inhibited right now because it's waiting on some safety permissives that aren't made. You'll also notice that there's this 442G MAB unit that isn't connected, and that's basically a safety gate interface, which we'll talk about shortly. My safety task, you can see I've got several programs and a whole bunch of routines, and it's a fairly complicated safety system. So you can imagine why I'd want to get in and test the code, see how it responds to various faults and recovers. This is the SFX instruction, and it's rather the glue to the advanced safety application. It translates the safe encoder that comes from my Kinetics ERS4 drive, brings it into the safety task, and then puts it into user units for me as well. And in this demonstration, I'm using degrees, but it could be anything. And this is my Emulate3D model. This is the 442G MAB unit that I mentioned. It's the safety gate interlock. So you can imagine this is used to protect an operator from getting into a fenced-in area. Safety gate might be closed and locked with this unit. It has the ability to lock the operator out, but yet provide access on proper demand. It's protecting the operator from this rotating load in this example. These are various requests that I can make to test my system, and then the status comes from the Logix safety task to indicate the resultant of these requests. I can see the speed in degrees per second. I can tell the position of the rotating member here on this part of the display. And we'll get into some of the other pieces later, but essentially I've got my reset, start, and stop buttons here to command my machine. So I'm going to go ahead and connect it to the system. This is the connection to Logix. So I'm starting the connection to Logix, and you'll see that the MAB are tags in my model, and it's going to make a class 1 connection to pretend that it's the safety device on Ethernet that this 442 device would be in person. But again, I have no hardware in front of me, so it's simulating that. It made the connection went green. But what does that mean in Logix? Let's bump back to Logix for just a second here. We see now, after a second here, that the 442 will go running and that my IOOK is now satisfied. So it believes that there is a safety gate out there because Emulate is providing that functionality to us. Fantastic. Now we're back in Emulate3D and we're going to start the model. So I'm going to reset and run the model. I'm going to enable some trends here in my model so you can sort of see what's going on. We've got our actual speed, we've got some other pieces that we'll talk about, and then the STO, which is off right now. The safe torque off outputs from Logix are off right now. I'm going to reset. Actually, I'm not going to reset. I'm going to stop and home the axes. And you'll see now that the position, which rolls over at 360, so it could say 0 or 360 at any given time, and this are both aligned. That aligns my safety encoder to my motion axis. So now I'm going to reset and start the system. And it's going to ramp up to the application speed, which is very slow, but shows well over Teams and in videos over the internet. It's going to ramp up to the commanded speed, the application speed of 100 degrees per second. Now, I can't get into the dangerous load. I can't even open the gate right now. It's locked, as you can see by the unlock bit being false. Therefore, the lock is activated. I can't get in and do anything because that's too dangerous. I can e-stop the system, and it's going to do by default what's called a safe stop 1. And a safe stop 1 is defined as ramping down to 0 speed under control and then turning off the STOs to disable the drive and incapacitate the drive, if you will. So it indicates that safe stop 1 worked properly and the drive is now disabled. I could get in and do some things if I unlock the gate, but I'm not going to do that right now. I'm going to reset the system, start it back up, put it back to my application speed of 100 degrees per second. But now I'm going to switch it to a safe stop 2, which we're going to see what that does differently. I'm going to e-stop the system once again while it's running. It's going to do the same thing, ramp it down to a 0 speed, but you notice this time, by definition, a safe stop 2 means leave the access enabled. So that access is still enabled. STOs are made, and we're still dithering. We're still sitting at 0 speed. We're at S2, safe stop 2 standstill. Very cool. This time I'm going to start and run the machine, put it back into a safe stop 1 condition. I'm going to demonstrate the safety function of the safe limited speed request. So I'm going to request that it goes to a safe limited speed. And a risk assessment would determine what that speed is. In my demonstration here, I have to be below 20 degrees per second, whatever that does to make it so it's safe for the trained operator to be around. As long as I stay under 20 degrees per second, I'm safe. So you can see I'm commanding 15, which is below 20. So I'm running at safe speed, and it indicates that safe limited speed is okay. I still can't get in though. So what I have to do is grab the operator pendant, and I squeeze that pendant. I'm not going to get into how it works, but it's got some neat features in it as well. And now I can actually open the gate, get in and do the tasks that I'm trained and allowed to do while the axis is still spinning at the safe limited speed. So let's say it's a print head and there's some goop on it from ink that dripped or whatever. I can wipe that off. Let's say it's my winder and I have to re-thread the needle. So I can go in and do that at safe speeds. Again, I'm trained, a risk assessment was done, et cetera, et cetera. So I'm done with that task. A little bit hard to close the door in Emulate3D. So now I've closed that. I'm going to flip the lever back up, and it's still unlocked. So I'm going to press the go ahead and lock button. And you'll notice now that the unlock goes false. A little hard to see in yellow. But it will still fault if I do anything but now let go of the pendant. So I'm letting go of the pendant. We're still at safe speed. I can now turn off the safe limited speed request, and we're back without any faults to full speed, 100 degrees per second. What did that do? Well, 10, 15 years ago, before safe speed, I would have had to have locked out and tagged out that machine. I would have had to stop production, gotten my power turned off, all sources of energy turned off, gone to the lock, and put a lockout tagout tag on there with my name, and then possibly scrap product, and then rethread the needle, and then restart and rehome. It could have taken 60 minutes, 30 to 60 minutes on average for me to perform that simple task with lockout tagout as my only tool. But with the advanced functional safety capabilities we have today with these ERS4 drives, it took a few seconds to do what I had to do. And we never stopped production. We were at reduced capacity, but we didn't stop production. It's fantastic, the capabilities that the advanced safety brings to our manufacturers. I'm going to show one more of the advanced safety functions, and that's going to be the safe limited position. So let's say that my machine has two zones, one where an operator or a tow motor or another machine member goes in and out, but the system can't be operating. The motion system can't be moving around while the loader or unloader is in zone 1. It has to be over in zone 2. So we're going to call that the safe limited position. So I'm going to invoke the safe limited position. Maybe I have to put a new pallet in for a palletizer or something. So the system is going to stay between 90 and 270 degrees in this story. So you can see it's being told to go from 95 to 265. Again, it can't go farther than 270 and can't go back towards home closer than 90, because let's say I'm in the 0 to 90 range and I can't have it over there. And if it goes into my range, it's going to fault out immediately. So here it is polling back and forth. And once again, I can go in to that safe zone and do whatever it is that I need to do safely away from the moving member. And I have to press this button again to lock the safety system. And then with it locked, I can then restore it to fully functional. Once again, never stopping production, never faulting the system, because I'm a properly trained professional and the risk assessment says I can do certain things. That is safe limited position. The last piece I'd like to talk about is the safety validation steps. Every machine builder has to simulate faults that might happen on a safety system and see how the system responds. So imagine that every e-stop is a two-wire device. They might short the two wires together. They might take one of the two wires to ground, or if it's in the off state, low state, they might take one to high and validate that the safety system detects that and faults and puts the hazard into the safe state. I'm not suggesting that Emulate3D can take the place of that. What I'm suggesting is that it can be used to check the code that drives those safety functions. So I'm going to, with the running system, create an e-stop fault. And that might indicate that something went wrong with my two-wire e-stop button. And I could look up in my user manual what this means, but essentially it stopped the hazard and did what it's supposed to do. And there's a number of other different checks that I can do in my safety system once I remove the fault and reset this. Oh, actually have to cycle it and then remove the fault, and I can restart the system once again. So these tools can then be used to save time in the safety validation steps. The customer will still have to short the wires together and do the sorts of things that they would do, but they're not going to be struggling with the code and the recovery of the code because they will have tested that in access test mode using Emulate3D or another type of emulation system. These are fantastic time-saving capabilities that allow parallel development for controls engineers who are typically squeezed to get the machine out the door at the end of the build. Thank you for your attention today.